Hello, good evening to all of you. My name is Masud Rana. Today I will teach you carbon and its compounds. This is a very important topic in chemistry as well as in science. So without any delay, let's start the topic. At the very beginning, we have to know the presence of carbon. So carbon is found in atmosphere, in the Earth's crust, and in all living organisms. Carbon is also found in fuels like wood, coal, charcoal, petroleum, biogas, etc. Carbon is present in compounds like carbonates, bicarbonates, and carbon in the free state is present in diamond, fullerene, or in graphite. So we have to know the bonding in carbon compounds, the covalent bond of carbon compounds. The atomic number of carbon is 6, so its electronic configuration is 2,4. So it has 4 valence electrons, and it can attain stability by either gaining 4 electrons or losing 4 electrons, or by sharing 4 electrons with the other atoms. Generally, carbon cannot gain 4 electrons. Why this is so? Because it is very difficult to attain or hold 10 electrons by only 6 protons. And carbon cannot lose 4 electrons also, because it is high amount of energy is released. That's why it cannot do so. So what is happened in the case of carbon compounds? It shares its 4 electrons with the other atoms. Since the carbon atom needs 4 electrons to attain stability, its valence is 4. So it is tetravalent. Now you can see the Lewis dot structure of carbon compound, and here carbon is forming 4 covalent bonds with the other atoms. Now let us take a look of the formation of covalent compounds by carbon atoms. The covalent bond is a chemical bond which is formed by sharing of electrons. The word sharing is very important. The sharing of electrons between 2 atoms. The sharing of 1 pair of electrons results in the formation of single covalent bond, whereas 2 pair of electrons give 2 covalent bonds, 3 pair of electrons give 3 or triple covalent bonds. Let us have a look the formation of single covalent bond. For example, hydrogen molecule. The atomic number of hydrogen is 1. Its electronic configuration is also 1. So it has 1 valence electron as well. So it needs 1 more electron to attain stability. So 2 hydrogen atoms share the 2 electrons and results in the formation of hydrogen molecule. As we can see in the picture, the hydrogen atoms combine to form hydrogen molecule, forming a single covalent bond between the hydrogen atoms. Next, the formation of double covalent bond, the oxygen molecule. In the oxygen molecule, the oxygen have atomic number of 8. Its electronic configuration is 2, 6. So it has 6 valence electrons. So to attain stability, it needs 2 more electrons. That was 2 oxygen atoms share 2 pair of electrons, results in the formation of 2 covalent bond in the oxygen molecule. Here the image describes the thing that the oxygen atom combines with the other oxygen atom and form 2 covalent bonds between 2 oxygen molecules. And lastly, the triple covalent bond, that is in nitrogen molecule. The atomic number of nitrogen is 7. Its electronic configuration is 2, 5. So it has 5 valence electrons. It needs 3 electrons more to attain stability. So two nitrogen atoms share 3 pair of electrons, resulting in the formation of triple covalent bond in the nitrogen molecule. Here we can see the nitrogen atom combined with the other nitrogen atom, and they share 3 electrons to form triple covalent bond. Formation of a very large number of carbon compounds. Carbon forms a very large number of compounds. The number of carbon compounds is more than 3 millions. It is more than the number of compounds formed by other elements. This is because carbon atom can form bonds with the other carbon atoms to form long chains like this, or branch chains, or ring chains. This property is called as catenation. Since the valency of carbon is 4, it can form 4 covalent bonds with carbon atoms or with other atoms like hydrogen, oxygen, or nitrogen. Now lastly, the hydrocarbons. What is hydrocarbon? The compounds of carbon and hydrogen. The hydrocarbons are majorly classified into 2 types, the saturated and the unsaturated hydrocarbons. The saturated hydrocarbons having all single covalent bonds between the carbon atoms. For example, alkanes. Alkanes have all single covalent bonds between the carbon atoms. And their name ends with "ane", like methane, ethane. The pictures are shown here. This is the methane molecule and this is the ethane molecule. Now, the next, unsaturated hydrocarbons. They having a double or triple covalent bonds between 2 carbon atoms. For example, alkenes or alkynes. Alkenes have a double covalent bond between 2 carbon atoms and their name ends with "ene", like ethene, propene, like that. Here are the 2 carbon atoms on the left hand side. There is 2 covalent bond between 2 carbon atoms, and propene have 3 carbon atoms where the 2 carbon atoms form 2 covalent bond. Now the last, alkynes. Alkynes have a triple covalent bond between 2 carbon atoms and their name ends with "ine", like ethyne, propyne. Ethyne have 2 carbon atoms having 3 covalent bond together, and propyne have 3 carbon atoms and the 2 carbon atom have 3 covalent bonds. So that's it for now. Thank you.